guys, the first problem we're starting with is number 17. It says the graph of y equals a to the x is shown below, or is shown below. It should be shown. I guess I made a typo. If you look at this graph, you can tell it's exponential. It's got an exponential increase. So just for review, before we even look at the rest of the problem, what does that tell you about the value of a? What kind of values can a take on? A has to be what? Positive is good. What value though? What positive values can it take on? Definitely over 0. That's positive. A little more specific. What can it take on? Huh? No. It's not even or odd. Okay, I'll give you a hint. I'm looking for values between 0 and 1 or greater than 1. What does it have to be for exponential increase? Yeah, it's got to be greater than 1. Anything between 0 and 1, and I'd have an exponential decrease. Okay? But your exponential increase suggests that a would have to be bigger than 1. Okay? And that's without me doing anything on the problem, without looking any further. I can take a wild guess that a is going to be bigger than 1. Okay? Just the way the function is written. So if you scroll down, they're asking you to say which choice is closest to log base a of 3. Okay? So the question is, how do I do that? They're wanting log base a of 3 is equal to what? Okay? And they give you some values here. Okay? So let's think, what are we doing? Okay? What are we asked to find? And then we'll go from there, okay? So if I switch over to the dot cam, man, oh man, oh man. There we go. All right. All right, so we have y equals a to the x as our function. We have log base a of 3 is equal to something, okay? Can I rewrite this as a logarithm? Okay, how would I do that? I would do log base a of y is equal to what? Log base a of a to the x, right? And then this x comes down. So I really get log base a of y is equal to x. So over here, if they're asking me this, what am I looking for? If this is the case, what are they asking me to find? X. They want to know x when y equals what? Log of x. No. When y is equal to 3. Okay. So all you have to do on this one is rewrite your function as a logarithm and compare it to what they're asking about. Okay. And they're saying, what's the x value when this y value is equal to 3? Okay. So then it's just a matter of going back to your graph. So we'll scroll back up. And we're going to look at y equal to 3, which is right here. And you're going to scroll over. And go down. That's just sitting to the right of 2. Okay. So if I go down here to my values, which one is just sitting to the right of 2? It's that 2.1. Okay. All right. All right. So I get x is equal to 2.1, and we're done. Guys, if I wanted to do this like really exact and not eyeball 2.1 on the graph, is there a way to do that? Could I actually find out what a is equal to? Yeah, you actually could. All I would have to do is take this point, which is 3, 5, and plug that in to y equals a to the x, and then solve for a. Okay? And once I know a, I can come down here and say log base a of 3 and get my x using that log base formula on the calculator. How many of you remember how to get the log base on your calculator? Do you remember that? And I'm not going to work through that, but I'll leave that for you guys to work through. Plug in the x and y and solve for the a, and then actually do log base a of 3 and see if it comes up to 2.1. Okay? You might get something close. It may have more decimal places, but whatever. Okay, can y'all see that? No. Can you see that at all? Not really. Do we need to kill one of the light switches? I don't know if I turn both of them on or just one. All right. Is that better? Sort of. Yeah, that's better. All right. So again, if I want to do the log base formula, that should be alpha window. And log base is going to be, what, option 5 here, I think. I can't read it at that angle. Yeah, that's option 5. Okay. And then you just plug in the value of A and plug in the value 3 and then hit enter. Okay. All right. Do y'all want to see that work, plugging in the X and Y? I mean, how you would solve for that? At all? Yay, nay, hearsay, yay, hey. All right. What's the point, X and Y? I'm going to do it anyways. X and Y is equal to 3 and 5. All right. So if I want to actually solve for A, and I'm just really uptight and I want it perfectly right on my test, okay, then I'm going to say X is equal to 3. So Y is equal to 5. So I'm going to 5 equals A to the third power. And then what I'm going to do here is say that my A, to solve for it, I'm going to take the 1/3 power, which is the cube root of both sides, and I'm going to get A equal to 5 to the 1/3 power, which is a cube root of 5. Okay. And then X, we know up here, is simply log base A of Y. We know the Y value is 3. So you're going to be log base of cube root of 5 of a 3 is equal to what? Okay. And you're like, well, that looks kind of freaky, but it's okay. You use log base. You do alpha window, option 5. Down here, math, we'll do a cube root, right? Math 4 is your cube root of 5. Then I go up top and put a 3. No, I didn't do that right. Delete. I got to get up there. No. There I am. Do y'all see that? So you got log base A, that A is cube root of 5 of 3. And I get what? 2.0478. So I think their calculation is a little bit off if they got a 2.1, which tells me they eyeballed it. They didn't find the exact value. Do you see that? There's no way they found the exact value and rounded to 2.1. But anyways, but now you know the rest of the story and what it actually is. Okay. But 2.1 for eyeballing on the graph, that's pretty good. Okay. But exact value is actually 2.04. All right. Any questions on that one? Again, you're given an exponential function. They're asking in terms of log base A of 3. The goal there is just rewrite the function as a logarithm and go from there. Okay, substitute what you know. All right, so let's back up. And that's number 17. And we'll go for what? Number 18. We can get down to it. No, it ain't. It's going to be difficult. Just wait for it to finish loading. Mm-hmm. Is that it? See, I can't even scroll. Why? This is being difficult. Can't even scroll. It's apparently going to be a slow network day, guys. So, all right. Can I scroll now? No. Yes. But not very smoothly. All right. We just did 17. Number 18, about half the class, actually not half the class, half of every class got this right. So most people do a little bit better on this problem. So let's see what it is. All right, it's a log problem. See, y'all just impressed me. You know that? I mean, I'm telling you that exponentials and logs right over my head in high school. And you guys, that's your best problem. I'm like, that's pretty amazing. So what is the meaning of the base of the function y equals negative log of x? And that is a common log, and common log has what base? 10. Okay. So it says as y decreases by 1, x increases by a factor of 10. As y decreases by 1, x increases by a factor of 10. As y increases by 1, x increases by a factor of 10. As y increases by 1, x increases by 10. Okay. Notice increases by a factor of 10 and increases by 10 are two totally different things. One is 10 times the previous value, and one is just add 10 to the previous value. Two totally different things. So if you notice right here, this y decreases by 1, x increases by a factor of 10. How does that work? Why is that the correct answer? I mean, imagine that x were like 1,000. What's your y equal to? The 1,000 is 10 to what power? 3. And the y value does what? Okay. It gives you the exponent, right, when you do a log. And that's actually a negative 3, right? Because you got a negative out front. So don't overlook the negative on the problem, okay? So let's look at the function and we'll list out some values and see what happens, okay? So if we look at this list, and this is problem what, 18? You have y equals negative log of x, and we're going to do some x values, and we're going to do some y values. So if I do x equal to 10, my y is equal to what? a negative 1, right? Because that negative out front. If I have x equal to 100, then my y is equal to a negative 2. If it's 1,000, y equals a negative 3. Okay, just with that small table right there, we can go back to these statements and say as y decreases by 1, which way is decreasing?
Down.
This would be decreasing by 1. Okay. Then what happens to here? This is an increase by 10 or a factor of 10? Yeah, by a factor of 10. And then you go back over here. As y decreases by 1, x increases by a factor of 10. So again, all I need to do is create a short table of values and then look at what's happening here with x and y and compare it to the statements that are being made. Okay? And that's just pure observation. And all you have to know, guys, is that key thing of the logarithm of a number returns the power that you would have to raise a base to get that number. Okay? So if I'm taking the log of 100, well, that's log of 10 squared, and the base is 10, so it throws back the exponent 2, but it's a negative 2 because of the negative out front. Okay? So again, I don't even have to punch my calculator. If you have to, don't worry about it. Okay? You can do that. No one's going to fault you. But again, if you remember that rule for the logarithm, it's just the log returns the exponent that you'd raise the base to get that number. So anyways, does anyone have any questions on that? Do you see how it's just an observation of what's happening if you'll list out the x's and y's? Okay.
If it was positive, would I do the same thing?
If it were positive here, then you have an issue. That should say increases by 1. Then this increases by a factor of 10. Do you see what I'm saying? But that negative is what's causing that decrease by 1. Okay. So it's actually going the opposite direction, which is kind of wild. But it's because your negative sign flips that log function over. It reflects over the x-axis. So what you would normally see as this is now flipped over and becomes what? Is it like that? Ish, like that? You see? So my x is increasing, but my y values are decreasing. Okay? As you're moving to the right. All right. And just for sake of review, what is that point right there for the log function? It's the x-intercept, but where does it intersect? It's log of 1. Okay. Log of 1 is 0. What's log of 0? It never crosses the y-axis. It's undefined. What is log of negative 2? It's undefined. Your log function is only defined in quadrants 1 and 4. Yeah, 0 or anything less than that is undefined. Okay. So don't let them trick you by throwing some freaky values on there. You have to know these right there. That's just your characteristics of a logarithm. All right. All right, so that's number 18. So we're going to do 19. And then let's see what this one is. Let's see how long it takes to switch. It could be taking a while too because we're doing the recording at the same time. You know, that may be slowing it up too. I don't know. But it sure is a pain. But I'm going to snag this. 37% got this right. I'm going to go ahead and click on it before it does anything else. guys, this is an application problem of logarithms. All right. So it says a solution's pH is given by the function. And again, if I'm working this, I'm going to write my function down. That's a negative log of t. So that's the same function we just looked at, actually, right? The behavior of it. It says where T is the hydronium ion concentration in moles per liter. All right, guys, do you have to know what hydronium ion concentration is? No. So when you read a problem like this, don't panic and freak out because the words are so big that I'd have to go to college for 20 years to figure out what it is. Okay? No. All you have to know is that's my function, and then what am I going to do with my function? Okay? You do have to know what the value of T represents and what the P represents. Okay? The pH is obviously the P, the T is the ion concentration, and they tell you units for that too. But it says a sample of coffee has a pH of 5. What is the approximate hydronium ion concentration of the sample? So all you have to do is reword that. Knock out the big words and say, if P is equal to 5, what is T? Okay? That's a simple way of phrasing that. So knock out the big words and replace it with that variable. Okay? So all they're asking you, if P of T is equal to 5, what is T? That's what they want to know. All right? So if I say 5 is equal to a negative log of T, then can I move this negative to the other side? Yes. So I'm going to say divide by -1. I get -5 is equal to log of T. What base is that? So can I exponentiate both sides? Yeah, I'm going to say 10 to the -5 and 10 to the log T is equal to T. So T is equal to 10 to the -5th power. So that's really what? Yeah. And if you want to do that on your calculator, like really easy, that -5 says what? Flip it over and raise it to the 5th power, right? So I could say on my calculator to type it in real easy, 10 raised to the 5th power, and then invert that. Do you see that? Does that make sense? I'm saying 10 to the 5th, and then I hit that x to the -1 key. Well, I got to hit the right arrow first to get out of the exponent. But then x to the -1 will flip this over, and that's really 10 to the -5 because you multiply exponents. And then I just hit enter. And you're like, gee, wow, that gave me 10 to the -5. So what do I do with the -5 there? Because they're not going to give me 0.00 or whatever. So how do I find that using 10 to the -5? This is t equal to 1. And I take that decimal. I go 1, 2, 3, 4, 5. So I'm looking at 4 zeros there because we're moving that decimal place to the left 5 places. Okay. And that's going to be answer choice B. All right. Does anyone have any questions on that as far as scientific notation? Yeah, if your calculator gives you that, it's just not going to spit out the 0.000001, whatever. You know, and that's kind of annoying, but all you do is take the 1 and the decimal to the right of it and move it to the left if the exponent is negative. All right. So that is your answer. All right, does anyone have any questions before we move on? So we got number 20 next. And we got 29 questions, so we should be good. We should finish this week. Like easy. So question 20, let me back up and see what that is. Oh Lord, I can't get, oh no. There it is. Come on, snag it, snag it. All right, 40.7% got this question right. So again, that's out of the 30% range, which is pretty good. So guys, this one, you need me to zoom in a little bit? All right, are y'all listening? Y'all listening? All right, guys. This says which function results by shifting the graph of y equals natural log of x plus 3 minus 6 to the left 4 units and down 3 units, okay? So we're going to take this function and we're going to write it on our paper, natural log of x plus 3, and then minus 6. Hey, Maya. How are you doing? Oh, good. They got late bus slips now. That's good. All right, I'm going to have, they'll probably correct it if I don't, but I'll go in later because we're recording what we're doing right now. So later you can go back and watch the problems you missed. So you hadn't really missed anything if that's the case. All right, and we're trying to move this function to the left 4 units, and we want to go down 3 units. Okay. So if I'm looking at both of these guys, which of these numbers represents the vertical shift? Because that's always the easiest one to start with. Huh? No. It's always the one that's outside your actual function. It's the one that's the constant that you've added or subtracted to the function or from the function. Okay? So this function, the natural log of x, is actually shifted down 6 units, and you're wanting to move it down another 3 units. And down, do I add or subtract to do that for the vertical shift? You subtract. So you're basically going to take this function, x plus 3 minus 6, and we're going to subtract 3 more units. Okay? So we get y equals natural log of x plus 3 minus 9. Okay? So if I go back and look at my answer choices, and I'm pretty confident that I know where that vertical shift occurs, and I'm pretty confident that I went the right direction by subtracting 3, then I can come over here and automatically rule out answer C and D. So even if I wasn't quite sure if I add or subtract on the horizontal shift, I can definitely rule out C and D and give me a 50-50 chance of getting the rest of it right. Okay? So just being confident on your vertical shift increases your chance of answering this question correctly. Okay? Now we said the difference between the vertical shift and the horizontal shift, and your horizontal shift occurs inside here. But the difference is your vertical shift happens exactly the way you think it would. If I add a constant, I'm shifting up. If I subtract a constant, I'm shifting down. But your horizontal shift, if I'm adding a constant, I'm actually going to the left. So it's opposite of what you think. If I'm subtracting 3, I'd be moving to the right. Okay? So unlike the vertical shift, the horizontal shift behaves exactly opposite of what you think. Okay? So if I want to go left 4 units, then we're going to say natural log of x plus 3, and then I'm going to add or subtract 4 units. If I want to go left, I'm actually going to add 4 and then minus 9. So we should get natural log of x plus 7 minus 9, okay, if we're thinking about it correctly, okay? And then I go over here, and I have y equals natural log of x plus 7 and then minus 9. Now, guys, how can I double check this? Let's say that I'm really uncertain that I made the correct choice on the horizontal shift. I'm still feeling confident about vertical. Yeah, graph it. That's all you got to do, okay? So if we graph these two, so let's go to our calculator, and we're going to go to y equals, and we're going to say natural log of x plus 3 minus 6, okay? And then the next one I'm going to do natural log of x plus 7 minus 9, okay? And I'm going to come over here, and I'm going to graph this one with a bold line. So my shifted function is going to be bolded, and the other one's just going to be regular. So I can tell which one is which, okay? So the bold one is the shifted one. The regular one is the original, okay? So if I do zoom 6, are you serious? I must have stat edit or something on here. No. Got a stat plot. Yeah, my stat plot's still turned on. All right, that's what it is. So go to y equals and then hit zoom 6. All right. So I have my regular function here, and then I have my bold function. Now, was I supposed to go down 3 units? Does it look like it shifted down? Yeah. Did it shift 4 units to the left? Yeah, it definitely went left, right? So I can tell graphically that, yeah, this is pretty correct. Okay. All right. So again, do the work, check the work. Okay. Just double check what you do. Okay. Because if you can graph it out and check it, that's fine. I would not go through and try and graph every single one. Okay. I would think through it right here, work it out, and then graph it to check it. But if you sit there and have to graph each one and check each one, you can't tell exactly how much it shifted for one. But also, that's a lot of calculator work on one problem, and you're going to be wasting your time. Okay? So you don't want to camp out on any given problem. Okay? So do your smarts right here, and then check your result. Okay? All right. Does anyone have any other questions on that one? So just remember, vertical shift occurs outside the function. The horizontal shift occurs inside the function where you add or subtract from the value of x, and that shifts your function to the left or the right. The vertical shift occurs exactly how you would think. Adding a value shifts up, subtracting a constant shifts down. Horizontal is exactly the opposite of what you'd think. Adding a constant shifts it to the left, subtracting a constant shifts it to the right. Okay? So you got to remember those two. Okay? All right. So next stop, 21, blackjack. All right, 21. I can't scroll, guys. I can't scroll. The following pages have become unresponsive. SchoolNet, blah, blah, blah. Let's wait. And we want question 21. All right. Mm. All right, this one, guys. This is simply a piecewise function. It's shown below. For what value of p will the function be continuous? First of all, guys, what is continuous? What does that mean? Nonstop. Uh, Not necessarily infinity. I can be continuous between 2 points, or I can be, negative infinity to positive infinity. But here, when you have a piecewise function, you have the potential for a disconnect, where the function goes up here and then it continues from down here, or vice versa. To be continuous, they want these 2 points to line up. They want you to be able to trace that function with a pencil and not lift it off the paper. And just keep on going. Okay? If there's a disconnect, the y values are different at that boundary, then I have to lift my pencil and continue on. That's discontinuous. Okay? So if they're asking the value of p that would make this continuous, then I'm looking on here and I see I'm graphing between the values of x equal -4 and x equal 5, but the boundary point is at x equal 3. Okay? So you need the y value here to be equal at x equal to 3. Okay? So all you have to do on this problem is to plug in x equal to 3 in each of these pieces and set them equal to each other. Because that would be h of 3 for the first piece, h of 3 for the second piece, and you're requiring those two to be equal. Okay? So if you do that, let's copy the function down. H of x equals -2x squared plus 5x plus 10 from -4 less than or equal to x less than 3. And then you have 2x plus 3p from 3 to 5. Okay. All right. So again, the boundary, if you recall on piecewise, the boundary is at x equal 3. Okay. To be continuous, we require the y values of each piece to be equal at x equal to 3. Okay. All right. So guys, what we're going to do is we're going to take this piece, -2 x squared plus 5x plus 10 at 3, and say that has to equal to 2 times x plus 3p at x equal to 3. Okay? And again, once you do that, guys, this is an easy problem. Okay? All you have to do is know what to do to it, and you get this nice, easy problem. Okay? So you get -2 times 9 plus 3 times 5 is 15 plus 10 is equal to 2 times 3 is 6 plus 3p. So you're going to get -18 plus 25 is equal to 6 plus 3p. And what's 25 minus 18? Is 7. Okay, so we get 7 is equal to 6 plus 3p. And I'm going to subtract 6 from both sides and get 1 is equal to 3p. And divide by 3. So I get p is equal to 1/3. Okay. And then I'm going to go back to my answer choices. And I do get p equal to 1/3 there. Okay. Now, guys, is this something I can sit here and pick and choose these? I could say let x equal 3. You still have to know that boundary point, where the two functions split off. So I would still plug in x equal 3, but then I could go back in and check each value here by substituting p into the second one and see if it equals the first one. Okay. So you can kind of guess and check on that one. But it's, again, easy just to solve it out. It wasn't too bad. Okay. It's just substitute and solve. All right. Now, guys, you don't have to raise your hand, but again, I'm going to ask the question. Is there anyone that you substitute in this and you're like, I still don't know how to solve that algebraically? And you're just like, I don't know how to do that. Again, if that's the case, you just have to know a little bit of calculator work. I can take all of that, even if I'm uncertain how to do this, like you're one of those that you're still trying to do 3 times 2 there and get a 6, and you cannot do that to an exponent, but maybe you're one that keeps messing that up, then type that straight into the calculator under Y1. Right here, type this under Y2, but this P value is going to be your X. Okay, that's your X when you type it under Y2. And then all you have to do is do second, trace, option 5, and that is intersect. So you're going to intersect your left-hand side with the right-hand side, and the value you get for X is sitting right there. It's going to be 1/3. Now it's going to give you a 0.333333. You got to be able to recognize that's 1/3. Okay, it just is. But yeah, if I'm telling you, if you know how to set it up, but the algebra is still kicking your tail, again, solve it on the calculator. You can do that. No one says you can't. You have your calculator on the test. No one's stopping you from doing that. And you can get just as correct an answer as the next person. Okay? Does that make sense? And guys, that technique works on any equation. Okay? Even the ones we saw a while ago with the negative log of t, blah, blah, blah. I can graph the left hand and right hand side there and solve the problem. If I can't remember how to exponentiate both sides and do all that kind of stuff, isolate the log first. You just type the left and right hand side and graph it and do that right there. And you'll still solve it. Okay? Not a problem. Okay? All right. Let's see. That was 21. So let's do 22. What time is it? 8:57? Let's back it up. Okay, item 22, about a third of the class got. So, the guys, about half the class got 21 right. That's not bad. I don't know what this thing's doing. It's being rather slow. I'm sorry, guys. Yeah, I'm sorry. I think the recording is slowing down the screen, the browser. I mean, SchoolNet can be slow sometimes, but I'll give it credit. It ain't usually that slow. I mean, really. All right, guys, this one you have a piecewise function that's graphed below. Okay. All right, guys, looking at this, guys, we have a piecewise function graphed, and they want us to, I guess, find the function that represents this graph. Okay. So if I'm looking at this right here, before I even start looking at my answer choices, can we examine the graph and see what do you see? You know, what kind of observations do you make? First of all, where are my boundaries? Where are the boundaries on this graph? Yeah, -5 and 0. Okay. We have some open and closed circles here. How many of you remember what those signify as far as the function? Where does that show up on our function? The open and closed circles. Do you remember what part of the function that pertains to? Where have you seen open and closed circles in the past? What were you graphing? Yes, you're looking at inequalities, right? So when you break this domain up and this piece of the function here, you're looking at x less than -5, right? Here I'm looking at x greater than or equal to -5 and less than, don't pull the y value, the x value is 0 there, okay? And then this one's just x is greater than or equal to 0, okay? So when I go to look at my functions, that's what I'm looking for also. I also see that I have what type graph listed first? It's linear. Is it a positive or negative slope? Is a negative slope. If you are going from left to right and that graph is decreasing, that's a negative slope. Okay. What about this? It's a what type function? It's a quadratic. The leading coefficient is positive or negative? Yeah, it's going to be negative. So, guys, I'm not even asking what's the particulars of the function right now. I'm just saying what are characteristics that I can use to rule out some of my answers. Okay. What type of function is sitting right here? That's kind of a weird function, right? What type function behaves like that? Not exponential. Exponential, the domain is all real numbers. This one's cut off right here. Okay. So what do you think that is? It kind of looks like a parabola, but it's turned sideways, and you're only seeing the upper half of it. That would be a square root function. Okay. So I'm suspecting that somewhere down there in my equations, I'm going to have a square root function, which is normally sitting at 0, but this one's been shifted down -1. Okay? So anyways, let's go down here and see what we see. All right. Do I see my square root of x minus 1 right there? Yeah. I'm liking that. Do I see it on B? Yes. Do I see it here? Yes, but look at the greater than 0. That should be greater than or equal to 0. So just based on that, I can rule out answer choice C. Okay? Just looking at the third piece. This one right here, again, square root of x minus 1. Is that right? Actually, I did that wrong, didn't I? Oh. Square root of x minus 1, that is a horizontal shift to the right of 1. And that's not what you see here. So that rules out B and C and leaves only option D. But then look at this one. Because that's not greater than or equal to, that means this one has to be correct. Okay? And just to be safe, I'm going to check the other pieces. Do I have a negative slope on my linear piece? Yes. Do I have a y-intercept of -7 if I keep going down? Because as down to right one, 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 down to right one puts me at -7. Okay? So yeah, I got the correct y-intercept. X less than -5, is that an open circle? Yep, that matches. This right here, praise the Lord, they gave me what version here? What form of the quadratic is this? I hope y'all remember that. Because that is a gift right there. Yeah, it's basically your vertex form, right? You have x minus h squared plus k. The minus h is minus a -2, right? So I have a -2, 6 for the vertex. That is a -2, 6 for the vertex. I also have a negative out front, which flips it upside down. Okay? So that's exactly the function. I have a closed circle on the left and an open circle on the right. Here's a closed circle on the left and an open circle on the right. Okay, so everything about option A matches. Okay, but again, just looking at the third piece, we were able to easily rule out B, C, and D. Okay, and guys, if you're questioning the type of function there, again, they're giving you the function type. So even if you're like, I don't know that's the square root of x, you get the clue for it down here in your answer choices. So if you didn't know that off the top of your head, you pick it up right there. You just have to know that this -1 is a vertical shift, and the -1 under the radical is a horizontal shift. Okay? If you can make that distinction, you can rule out your other answer choices. Okay? I'm going to take a nap vicariously through him. Right, Samuel? I'm joking with you, man. I'm tired too. I said, I'm going to take a nap vicariously through you. It's all right. John was yesterday, right, John? Okay, we did 22, right? So we're doing 23. Let's at least do one more. Oh, we got some more in here too. I know. All right. I clicked on 23, guys, but it's taking a while. Like I said, I think it's because we're doing the recording at the same time, and it is the processor in this thing just can't handle it. I mean, really. And the Intel processors are supposed to be a little bit better at this, like for screencasting, than the other Chromebooks that aren't Intel based. So, okay, guys, look at this one. That's the nice one. Wait till I blow the whistle, it'll hurt your ears. And I will blow it as loud as I can. The equation y equals 4.7x to the 1 over 6 is graphed on the coordinate plane. How does increasing the denominator of the exponent transform the graph? Okay. So if I graph this function and I increase the denominator, how does it transform the graph? What is the first thing you would do with this?
Look at it.
Yeah, I can look at the equation, but what's the most obvious thing I'd want to do with it? Yeah, graph it. So I'm going to put the original function in, but then I'm also going to do one where I actually do what it says. I'm going to increase the denominator of the exponent. And then I'm going to graph those beside each other. Again, I can bold one of them so I know which is which. And then I'm going to read over my choices looking at my results on my calculator and see what happened. Okay? So let's do that. We're going to go to y equals. We're going to clear out what was there. And I still can't clear that out. There it goes. And we're going to type in 4.7 times x raised to the 1 over 6. All right. Let me hit enter. Then I'm going to say 4.7. Again, I want to keep the 4.7 there because they didn't say change that. Okay. They just said increase the denominator, right? So x raised to the what? 1 divided by, you want to do 9? Yeah, I think that's good. If I just increase it by 1, maybe the change won't be as pronounced. But if I make it a little bit bigger, it's going to be a little more pronounced so we can actually make a good judgment call. Okay? So I like your thinking there. Okay? So we got 1 over 9, enter. And again, I wanted to go to the left over here, the far left, and hit enter. Y'all can't see that, can you? I forgot to switch the thing. Can I zoom in on this also? Let's zoom in on the calculator so we can actually see this. Is that good? Does that show up decent? Is that better? Yeah. All right. Again, the left side, if I just hit enter once, it's going to give me the bold line. Okay. If you go to the far left over here. And then I really don't know what to set my window to. Okay. I know at 0, these should pass through the origin, right? So I think if I do a zoom standard, I should be pretty good. All right. So let's do a zoom 6 and see what happens. Kind of a freaky looking graph. Okay. What happened?
Yeah, if you found 170, you would not notice the change.
Okay, you got actually two things going on here, guys. One, did we have a 1 over an even exponent? A 1 over a 6? And then we switched to a 1 over 9, right? Well, the reason you got a bold curve right here is because a 1 over 9 is the 9th root of, which allows for negative numbers. If I do a 6th root of, that's comparable to a square root for which negative numbers are not defined. That's one reason you're 1 over 6 graphed over here, but not over on the left of the y-axis. Okay? So again, when you see that result and you're dealing with exponents, especially rational exponents, think in terms of the roots because a square root is not defined at negative numbers. Remember, those go complex. But your cube root is defined at negative numbers. So same for a 5th root, a 7th root, a 9th root. That's going to be defined at negative values also. But can I increase it some more and see what happens? Yeah, let's do it just for the heck of it. So we're going to come down here, and you want to do what? 1/12. Okay. And then graph and see what happens. Okay. I think that's good. So let's switch back to our comments. And you guys have this on your calculator, so be thinking about what you're seeing here. And let's look at what it's saying and see if we can make the good choice. And I know the answer choice is already marked, but think compared to this, why is it correct? Okay. And why are the other ones not correct? It says the transformed graph will approach a horizontal asymptote while the original graph will not. Is that true? Does this even approach an asymptote? I don't think so. Okay. The bigger number that gets, you're multiplying 4.7 by a larger number. So I don't think that's approaching an asymptote at all. It's going to be continually increasing, but not at a huge rate. But it's still getting bigger. A transformed graph will not approach a horizontal asymptote while the original graph will. Is that really a transformed graph? Sort of. Okay. Again, it's not approaching a horizontal asymptote, but neither is the original, right? So does B make sense? No. The transform graph, that's when we increase the denominator, will go to infinity slower than the original graph as the value of x gets larger. Is that what you found? Yeah, do you see that bold line is below the other one? They're both going to go to infinity as far as the y value is concerned, but the original graph gets there quicker, okay, than the smaller one, the lower one, okay, which is what they're calling the transformed graph. All right, D, the transformed graph will go to infinity faster than the original graph as the value of x gets larger. Again, that is the opposite of what happened, okay? So it looks like, yes, C is going to be your optimal choice there. Because again, these are neither one approaching a horizontal asymptote. So A and B are just ruled out. This function is always increasing, okay? But as it flattens out, you still can't say that it's approaching a horizontal asymptote. Again, as you take a 12th root of bigger and bigger numbers, you get a larger and larger number, okay? It's not approaching a horizontal value or a y value, okay? So you're looking at whether it goes to infinity faster or slower. Go with C, because it's actually the new transform graph gets there slower than the original, okay? So that's going to be option C. All right. And we're going to stop there, I guess. So that's what, 23? And then we'll pick up with 24 tomorrow. We should be able to get through 24 to 29 tomorrow if all goes well. And then we'll have what? Thursday and Friday, for, I guess, a little bit more review. But you guys can say, hey, can we look at some more of these type problems? If you want to see some different types in particular for practice, we'll do that. Okay. All right. So let me stop the recording.